Here, we attempt to analyze the spatial-temporal clustering of the percentage of charge of loans. And we are using the same data set, the Lending Club data, from 2007 to 2018. I'm sure you've seen this from the previous video. These are the trends in the total number of loans for debt consolidation in different states in the United States. You've seen this before too from the previous video. Here are the trends in the total number of charge-off loans in different states in the country. And as you can see from here, the trends in the percentages of charge-off loans looks very different than the total number of charge-off loans. As you can see from this figure, the percentages of charge-off loans peak around or slightly after year 2008 for some of the states, and after that they level off or decline. So once again, before we can proceed to do spatial-temporal cluster analysis, we first have to convert our data into a matrix. And we calculate the distances among the different observations, which are states in this case using the dynamic time warping metric. The dynamic time warping metric is preferred over the Euclidean method because it's more accurate. And here is how the matrix looks like with respect to the percentages of charge-off loans for the first 5 states. We don't have to print off the whole matrix. And after that, we can proceed to do spatial-temporal clustering of the percentages of charge-off loans in different states. And once again, the horizontal axis of this dendrogram represents the number of clustering solutions. This can be either 1 cluster, 2 clusters, or even up to 51 clusters because we have 51 states. And the vertical axis of this dendrogram represents the distance when 2 clusters are combined to form a new cluster. So once again, we want to know what's the optimal number of clusters that can best explain the hidden structure of the data. And we use the elbow method to find that out. It seems that the total within clusters sum of squares significantly decline from 1 cluster to 2 clusters, but we don't really see an elbow at 2 clusters. And the total within clusters sum of squares decline again when we proceed from 2 clusters to 3 clusters. But once again, the elbow is not obvious. So, just by eyeballing this diagram, it seems that the 2 cluster solution, or the 3 cluster solution, or even the 4 cluster solution are potential candidates. We are not sure yet at this stage. Because of that, we proceed to do the Stillhouse analysis to determine the optimal number of clusters. And as we can see from this diagram, the Stillhouse analysis suggested 2 as the optimal number of clusters for the Lending Club data. And to be more certain, we proceed to identify the optimal number of clusters using the Kalinsky criterion. And the Kalinsky criterion suggested 3 clusters as the optimal cluster solution. And because of that, we proceed to split the states into 3 clusters. When we cut the dendrogram into 3 clusters, this is what we found. We see 2 evenly distributed clusters, even though one is a lot bigger than the other. And we also find that there's one cluster consisting of only the Iowa state. Results from the spatial-temporal clustering can also be presented in this format. As you can see from this diagram, each color represents a different cluster. As you can see, Iowa is a distinct cluster on its own. The trends with respect to the percentage of charged-off loans are different, distinctly different in Iowa compared to other states. And states like Arkansas, California, DC, Idaho, Illinois, Maine, Michigan, New Jersey, Pennsylvania, and so on, they form another cluster. And the remaining states, they fall into the big cluster we saw in the dendrogram.